Welcome back, everybody. This is our fifth session in JEE Mains previous year questions for chapter Electromagnetic Waves of class 12th. Before this video, we have made 4 videos in this series, and all of those videos are available on our YouTube channel's playlist section. And we have also made related videos for previous chapters and same video for the NEET also. So if some of your friends are preparing for NEET, then you can guide them through those videos. And if you like these videos and you find them helpful, then do press the like button, share them as much as possible, and subscribe to our channel. And if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video. In the previous one, we covered up to around question 36 or something. I think this is one of the last one. Okay, now let's start with 36. So here, during the propagation of EM waves in a medium, electric energy density is double of the magnetic energy density. So here we are discussing regarding electric energy density and magnetic energy density. Now we know that electric energy density, that is basically energy per unit volume, is equal to half epsilon naught times E square, and same phenomena or magnetic energy density is equal to half into mu naught square by P. Now, to equate whether they are equal or not, what we can do, we know that speed of a EM wave in a vacuum is equal to C is equal to E by B, and that is also equal to under root mu naught epsilon naught. Now, squaring both of these sides, we will get E square by B square is equal to 1 by mu naught epsilon naught, and from this we can write that B square is equal to mu naught epsilon naught times E square. Now substituting it here, we will get half mu naught square. Oh, sorry, I wrote it incorrectly. It is basically, that is B square by mu naught. And now if we substitute it, so B square will be, here we will get mu naught epsilon naught E square divided by mu naught, and that mu naught get cancelled, and we will get half epsilon naught E square. So both of these are equal. So in options, that is option C, energy density is equal to the magnetic energy density. Let us move ahead. A lamp emits monochromatic green light uniformly in all directions. Lamp has a 3% efficiency in converting electrical power to EM waves and consumes 100 watt of power. The amplitude of the electric field associated with the electromagnetic radiation at a distance of 5 meters from the lamp will be nearly. So we know that for a lamp, actual power converted into EM waves, so that is suppose PEM, that will be 3% of 100 watt, so that is basically 3 watts. Now we know that intensity is equal to power by area, so this will be PEM by area, and from the EM radiations we know that I by C is equal to half epsilon naught E square. So from this, I is equal to half C epsilon naught E square. Now equating both of these two, so this should be equal to half C epsilon naught E square, and from these two we can form a formula for electric field. So electric field will be equal to under root of 2 PEM divided by C epsilon naught into area whole under. Now substituting values, we will get E is equal to 2 into 3 divided by 3 into 10 raised to power 8 into 8.85 10 raised to power minus 12, that is epsilon naught, and area, that will be 4 pi into distance square, that is 5, so that will be 25, 5 square, that is 25. And on solving, we will get it around 2.68 volt per meter. That is option B. Moving ahead, electromagnetic wave of frequency propagating along z-axis, amplitude is given, epsilon node is given, the average energy density of the electric field will be. So we have to find out average energy density. Now we know that normal energy density or UE is equal to half epsilon node E square. This is the normal relation for the energy density. But we have to find out average here, average value here. So we can say UE average will be equal to average of half is half because it is a constant, and average of epsilon node is again going to be epsilon node into, we can say, E average square. Now, what is the meaning of average here? That is basically RMS value. And we know RMS value will be E by root 2. So, this will become half epsilon node E square by 2 and basically 1 by 4 epsilon node E square. So, 1 by 4 into 8.85 10 raised to the power minus 12, and E square, that will be 16. So solving, we will get 35.2 into 10 raised to the power minus 12. And that is option C here. Let us move ahead. The magnetic field in a traveling electromagnetic wave has a peak value 20 nanotesla. Peak value of electric field will be. So we know that C is equal to E by V, assuming that wave is traveling in a free space. So we can write 3 into 10 raised to the power 8 into B, that is 20 nanotesla. 20 into 10 raised to the power minus 9 should be equal to E. And this will give us 60 into 10 raised to the power minus 1 or 6 volt per meter. That is option B here. Now let's move to the next one. A plane EM wave in a non-magnetic dielectric medium with given by electric field is given by this relation, with distance being meter and time in seconds, dielectric constant of the medium. So we know that if a wave is traveling in some medium, then its velocity will change, and from that we can find out the refractive index, and from further from that we can find out the velocity. We can find the epsilon. So here velocity will be minus of omega by k. Here omega is minus 50. So minus 50 by 4 into 10 raised to the power minus 7. From this, we will get 12.5 into 10 raised to the power 7. Now we know that material is non-magnetic. So this velocity should be equal to 1 by under root mu node, that is k, dielectric constant, into epsilon node, and this will be basically converted to V is equal to C by under root of K. Now we know that is, so from this we can write that under root of K will be C by V. Now C is 3 into 10 raised to the power 8 divided by V, that is 12.5 into 10 raised to the power 7. So from this we will get here 3 into 10 divided by 12.5. Now I'm going to approximate. I'm going to assume that this is 12. So let us, this yellow color is for approximation here. So root k will be equal to 3 into 10 by 12. This will give on 4. 10 by 4 will be give us around 2.5. Now squaring this, we know square of this will be 6.25. Now the nearest one that is matching with this, that is 5.8. So answer will be 5.8 here. You can do exact calculation, then you will get the same answer. So let us move ahead. Select the correct statement from the following. Electromagnetic waves cannot travel in vacuum, so that is wrong. Electromagnetic waves are longitudinal in nature. They are actually transverse in nature, so that is also wrong. EM waves are produced by charges moving with uniform velocity. So that is also wrong because EM waves are produced by the accelerating charges. Charge needs to be accelerated, and if it is accelerating means velocity is not uniform. Velocity is not uniform. Although it is possible that there is a charge, it is moving in a circle with a constant speed. Speed might be constant, but velocity needs to be changed in circle. Even although we have constant speed, velocity can change due to change in direction. So, if we had a here uniform speed, then it could be right. Now, option D, electromagnetic wave carries both energy and momentum as they propagate through space. So, yes, they carry both. So, option D be right here. Let us move ahead. Now, electromagnetic in waves in vacuum has an electric and magnetic component E and B, which are always perpendicular to each other. Direction of polarization is given by X, and that is the wave, and that of the wave propagation by K. Then, so we know that direction of polarization, that polarization, mind my spellings, happen due to visible component of light, and that visible component come from the electric field. So basically direction of polarization will be the same as the electric field. So we can say that direction of polarization will be parallel to electric field and it will be perpendicular to the magnetic field. And if we see, option A will be wrong, B can right, B can be right, C will be wrong, and D can also be right. Now coming to the wave propagation. So we know wave propagation is, well, for velocity we have relation that E V is equal to E cross B. So it will be basically uh, perpendicular to both E and B and parallel to their cross product. And if we see here, that in option B it is parallel to E cross B, and in option D it is parallel to B cross E. So option D will be wrong here and option B will be the right answer. Now let us move ahead to the next one. Here the electromagnetic wave of frequency omega and wavelength lambda travels in positive y direction. Its magnetic field is along positive x-axis. The vector equation associated with the electric field of amplitude E naught. So basically, wave travels in y direction. So we know that V is equal to E cross B. So wave is traveling along J. Now we have magnetic field along x-axis. So here we have I. So to get J here, we need to have K here. So electric field can only be in the Z direction. So if we see here in this option, we have positive Z direction and here we have negative Z direction. And also here wave is traveling in the positive Y direction. Here wave is traveling in the negative Y direction. So option C will be the right one. Next, the EM wave has a frequency passes from vacuum into dielectric medium with permittivity epsilon 4. Then we have to find out that what will happen to frequency and wavelength. So we know that frequency remains unchanged. Frequency remains unchanged, so frequency will not change. So here frequency becomes half, so B is cancelled, and here, that's coming to the wavelength now. Now we know for a relation we have velocity is equal to lambda times frequency, and frequency is constant, so basically velocity is proportional to lambda. Now in a dielectric medium with permittivity 4, assuming it is a non-magnetic material, so we have a relation that V will be equal to under root epsilon, that is the dielectric constant, into epsilon node into mu node, and this will be basically C by under root epsilon. And from this we know C is 3 into 10 raised to power 8 and epsilon is here under root 4. So, or we can write basically that ratio of, yes, yeah. So we can say that velocity becomes c by 2, or velocity reduces to half. Velocity reduces to half. So if velocity is reducing half, then lambda also has to reduce by half. So we can say wavelength will be halved. So here option A, wavelength is halved. Option C, wavelength is doubled, so C is wrong. And option D, wavelength remains unchanged, so that is wrong here. So option A will be the right answer. Now, electromagnetic waves are transverse in nature is evident by. So they are transverse in nature. That is only evident from the polarization of the wave, because interference, diffraction, and reflection can occur also with the longitudinal waves. So option A is the right one here. Now, the correct match between column 1 and column 2. So here we have radiations and wavelength. So we know that basically we have X-rays and we have gamma rays here. So gamma rays has the highest energy. Gamma rays has the highest energy. So they has the highest frequency. So they has the lowest wavelength. And lowest wavelength is given here 10 to the power minus 15. So B is going to match with 2. So if we see here, option A and B are rejected. Now coming to the radio waves, they are going to have the lowest, we can say, energy. So if their energy is lowest, their frequency is lowest, so their lambda will be the highest. And highest value is mentioned here, 100 meter. So C should match with the 1. And here in both of the options, C is matching with 1. And B is matching with 2. Now let's coming to the X-rays. Now X-ray has energy less than gamma rays, so their wavelength will be slightly higher than the gamma rays, and that value is 10 raised to the power minus 10 here. So D should match with the third, and here D is matching with the third. So C is wrong, and option D is the right answer. Let's move ahead. Choose the correct option, related wavelength of two different parts of EM spectrum. So here lambda is given and we have to compare the lambdas. So we know that lambda for X-rays, here we have X-rays, is going to the minimum, will be the most lowest value, or they will have the least value. And radio waves have going to have the maximum value of lambda because they have the lowest energy. So here we have radio waves less than X-ray, so option A is wrong, C is wrong, and D is also wrong. So option B is going to the right one. Now, given below in the left column are different modes of communication using kinds of wave given in the right column. So we have optical, fiber communication, radar, sonar, and mobile phones. So basically, we know that mobile phones communicate through radio waves. So D should match with S, or we can say, and if as here none of the option in D we are getting S. So if it is not matching with the radio waves, then it should be going to the infrared waves. Oh, not sorry, infrared. It should go to the microwaves. So D should go to R. Now coming to the optical fiber. Optical fiber, here we have infrared light, so only one light here. So optical fiber will match with Q. So A with Q. And sonar, we know that sonar is work on the basis of infrared, ultrasound. So C should match with P. And from these three, we can find out that option C will be the right one. Now in the next one, arrange the following EM radiation per quantum of order of increasing energy. So we have to find out increasing energy order. So here we have X-ray. So X-ray will have the highest energy. So C will be at the last. Now coming to this blue, yellow, and radio wave. So radio wave have the lowest energy. So D will be at the last. And then we have yellow light because it has a frequency lower than the blue light. And then we will have blue light, so A. So DBAC, DBAC, that is option C. Here, microwave oven acts on the principle of giving rotational energy, giving translational energy, giving vibrational energy, or transferring electron from higher to the lower levels in water molecule. So basically, microwave gives vibrational energy to the water molecules because they already have other modes of the energy. So option C is going to the right one here. Now again, here we have to find use cases. So X-rays, UV rays. So yeah, coming to the ultraviolet rays, they are absorbed by the ozone layer. So 4 will match with 4. Now coming to the X-ray, muscular strain broadcasting to detect fracture in the bones. We normally take X-ray of the bones. So 3 will match with 3. Now, infrared waves are heat waves. So, they are used to relieve, we can say, stress from the tissues or strain from the tissues. So, first will match with the 1, and the left one, second, should match with the 2. So, that is a direct mapping, and that is given in option D. Now, in coming one, we have microwave, X-ray, infrared, gamma, UV, radio, and visible parts of the spectrum denoted by this one. Then, which of the following arrangement is ascending order of wavelength? So, we have to adjust them in their increasing wavelength. So, if their wavelength is increasing, means energy must reduce in that order. And we know for the here we have gamma and X. So gamma is going to have the lowest wavelength, then we will have X, that is X-ray, and after that we know that we have ultraviolet, then we have visible V, and then we have infrared, so I, and we have radio waves, so that is going to be R. So this type of pattern should be there in the answer, and that is in option C. Now to the next one, match the list one phenomena associated with the list two part of the EM wave. So doublet of the sodium wavelength correspond to temperature associated with isotropic radiation filling in all space, wavelength emitted by atomic hydrogen in interstellar space, wavelength of the radiation arising from the two close energy level of hydrogen spectrum. So we know that sodium lamps emit light in visible region. So first should match with A. And now coming to the radiation arising from two close energy level of hydrogen. So assuming we are taking transition from first level to the second level in hydrogen atom. So then change in energy, that will be minus of 13.6 minus, and this will be plus 3.4. This will be 10.2 electron volt. And if you find the wavelength regarding that, that wavelength comes out to be, oh sorry, frequency comes out to be 2.46 into 10 raised to power 15 hertz, and that is in UV region. And if it is in UV region, we don't have UV region here, but we can map it to visible region. But visible region is already mapped with first, so we can say second should also go to A, and there is no option in given. Uh, in no, there is no option which is satisfying this condition. So all options are wrong here. Now let us move ahead. Here we have, again we have to match list 1 with the list 2. So 700 nanometer to 1 millimeter, 1 millimeter to 400 nanometer, and these kind of things. So now out of all of these, we know that for magnetron, the lambda lies between 1 mm to 0.1 meter. So that should match with 4, yani, or we can say 4 should match with the fourth one, and air is only one option that is matching with this. So option D will be the right answer. Now, photon of EM radiation has energy 11 kilo electron volt each. To which region of electromagnetic spectrum does it belongs? So we know frequency will be energy by H, and this will be energy should be 11 into 10 raised to power 3, and it is in electron volts, so 1.6 into 10 raised to power minus 90 divided by h, that is 6.626 10 raised to power minus 34, and this give us 2.7 into 10 raised to power 18, and this 10 raised to power 18 order belongs to X-ray region, so option A will be the right one here. Now coming to the last one, frequency of X-ray, gamma rays and UV rays are respectively A, B, C. So we know gamma rays has highest energy, so their frequency will be highest, that is B. Then we will have X-rays, and that is A, and then we are going to have UV rays, so that is C. So B is greater than A, B is greater than A, and B is greater than C. B is greater than C. So option A will be the right answer here. So hopefully whatever we have covered here is helpful to you. If you have any still doubts or suggestion, you can put them in comment section. I will try to implement or solve. And if you like this video, then do press the like button, share it, subscribe to our channel, and also if you like to donate us something, you can scan these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, again, thanks for watching, and we will meet in next video.